So the last page, I purposely stopped at example 5 so that today with example 6 we can kind of review what we left off with example 5. So you're going to find your zeros of a polynomial function using algebra or by graphing. If I use my calculator to put in the polynomial, I can graph it very accurately by finding the max and mins, using relative max and relative min on your calc menu. And I can use my calc zeros to find my zeros. So if I were to graph it by hand or graph it with my calculator, that's what I would do. But we're going to find the zeros using algebra, and then we're going to estimate what our graph looks like because you're not going to have a calculator on your test. So I want you to understand how that feels. So let's start. What's the first thing I should do when I'm finding the zeros by hand? Yeah, set f of x equal to 0. So we'll start there. F of x is 0. And I've got x cubed minus x squared minus 2x. Then what are you going to do? I don't want to put a line in between you because, bless you, this is not a quadratic function. It's for the third degree, right? So if it's not a quadratic function, we don't want to try to complete the square and turn it into a vertex form. So if the highest degree was a 2, then we could do that. But the highest degree here is 3. So what do I do back in x? Back out in x. So I've got 0 equals x times divided x, or taking x away from each one of these. I get x squared minus x times 2. So then I want you to factor this on your own. You do that by yourself. Whatever method you want. If you don't know how to factor, you're uncomfortable with it, then you better know how to do the quadratic formula. The opposite of u, plus or minus a square u, plus u squared minus 4ac, all over 2a. Make sure that you know it correctly. What's one of my binomials? X minus 1? X plus 1? X minus 2. So make sure your signs are correct because that's going to mess up your zeros. On here, because your product is negative, 1 times, there's a 1 in front of the x squared, 1 times negative 2, we're subtracting the factors of 2. We're looking for a middle term that's negative 1. Because that middle term is negative 1, the bigger the 2 carries that sign. And then the other one has to be a positive for them to combine and make that negative term. So, don't forget to set the x equal to 0. And the x plus 1 gets set equal to 0, and the x minus 2 gets set equal to 0. Lots of times you forget to set that one equal to 0. So that one's already solved. There's nothing to solve there. Here, subtract 1, x is equal to negative 1, and add 2, x is equal to 0. So there's lots of things that I know just by looking at the original function so that I can graph. So I'm going to zoom that back out. So if I were to estimate or sketch my graph without a calculator, I can become fairly accurate. The only thing I can't determine are my relative max and mins. So you're going to doubt that part of your graph. I could find my y-intercept. How do you find your y-intercept? Yeah, let x equal 0 and solve for y. So here, every term has an x in it, so won't y end up being 0? And isn't one of your zeros 0, 0? Okay, so I'm going to start off with plotting my zeros first. So I have 1, 0, 0. 1 at negative 1, and 1 at positive 2. So the other point that I can find is my y-intercept by letting x equal 0, which is one of our zeros, as we said. 1. Because one of my factors was x. On that one, yes, absolutely. But only if you have that. So then the other thing I want to look at is my right and left hand behavior. Is this an odd or an even degree function? What's your highest degree term in the polynomial? Yeah, so not because it comes first, but because it's the term with the highest degree, it is the x cubed. That means the whole polynomial has a degree of 3. So is this an even or an odd function? Odd. So with my hands, I'm going to do left and right hand behavior. So with an odd function, does the left and right hand behavior agree or does it disagree? It disagrees. So you have one going in one direction and one going in the opposite direction. Look at your leading coefficient. What's your leading coefficient? Positive. So what does that tell you about your right hand? Does your right hand behavior go up towards positive infinity or down towards negative infinity? Up. So if your leading coefficient is positive, your right hand behavior goes up. If it's negative, it will go down. So because it's up, my right hand goes up, so my left must do what? It must go down. So I know I'm looking like this. So when I sketch my graph, I know I'm starting up. That's known. But here I don't know. I just know I'm going down until I come back up to hit the second zero. Then I have to go up and come down to hit the third zero, but my left hand behavior is going down. So this is the part that's unknown. And if I were to sketch it on my calculator, I would put in x cubed minus x squared minus 2x into my y equals. And then sure enough, I have my 3 zeros, so I could do calc 0 to double check those, but they look pretty close, don't they? And I could do my relative max and mins to find my hills and valleys. So this one actually is smaller than that one. And if we wanted true accuracy, that's what we would find as our max and min, and that I wouldn't have to dash this part. Because you're not going to have use of that calculator. So is there any way for you to know that? No. So when you do sketch your graph on your test, make sure that you make that middle part in between all the zeros a dash. So questions on that? So I used my knowledge of the leading coefficient test to tell whether my right hand behavior goes up or down. I used my knowledge that it was an odd function to know that my left and right hand behavior did not agree. I used my algebra to find my zeros, and we sketched the graph from there. We got pretty close. All right, then we have this thing called multiplicity. The multiplicity equations look much different than the one we just worked with, correct? Everything's fully factored into binomials. The only way that you can tell your multiplicity right now with your skills is for it to be written in this way. So a couple of things that you need to know. And your book has a whole lot written on multiplicity, so I'm going to try to break it down into something a little bit more user-friendly for you. For something to have multiplicity, number one thing is f of x, or whatever your function is called, must be continuous. There must not be any asymptotes, no holes. Jordan, are we not writing this? I'd write it if I were you. It must be continuous over the whole domain. So your assumption is, you're not going to have a calculator, that if I give you a problem on multiplicity and ask you what's this multiplicity, you're going to make the assumption that it's continuous. So we're not going to give you something that you don't have the ability to graph on your calculator for you to say, oh, hey, that's not continuous. I mean, there are some obvious things, like you would have a variable in a denominator or a variable underneath a radical. Those are some obvious things. But when it looks like this, you're not going to have any restrictions, correct? You're not. So the second thing that you're looking for is, look at each individual binomial. You're looking at the exponents on each of those individual binomials. And the exponent, for our purposes, are going to be known as m. So if m, and so you might want to note that I'm talking about the exponent of that binomial. So if m is odd, the graph crosses the x-axis at that zero. So can't I tell what the zero is here? What's the zero here? positive 2. So if I said x minus 2 equal to 0 and solve for x, I'm going to get x equals 2. So I know that there's a 0 at 2. The exponent tells you the multiplicity. So the multiplicity of this particular binomial is a 3. That 3 is odd. So I know at x equals 2 that this graph crosses the x-axis at x equals 2. The reason why that's important is sometimes at these zeros, doesn't the graph just kiss it and come back down? Just touches it and bounces back off, it doesn't actually cross? Think of a parabola where the vertex is sitting on the x-axis. That's an example of where a graph might not cross the x-axis at a 0. So at those max and mins, it could just touch the x-axis and not actually go through. You can tell that based upon your multiplicity. So if it's odd, it goes through. So what do you think happens if it's even? So if it's odd, it goes through. If it's even, what do you think? It just touches it. So if, so you're going to have to squeeze this down here. So if m is even, then the graph does not cross, does not cross the x-axis at that 0. And then in parentheses, I'm putting a very technical math term, kisses the x-axis. It just touches it, bounces right back off. You will not be given a polynomial in the form of example 6 and be expected to get it into this multiplicity form. You'll be given it in that multiplicity form. So here's how the questions are going to be asked. So let's look at A, and I can sketch a graph just based upon my knowledge of the overall degree of the polynomial, whether it's an odd or an even function. I can figure out what the leading coefficient is, whether it's positive or negative. So that helps me with my left and right hand behavior. And then I can tell whether my 0 is going to cross, the graph's going to cross at that 0 or bounce off. So the first thing here, let's look at each 0 individually. So I have a 0, as we stated, at x equals 2. Then they're going to ask you what's the multiplicity. So we're going to abbreviate that for multi. So the multiplicity is whatever the exponent is, in this case 3. So it has a multiplicity of 3. And so does that tell you whether it crosses or does not cross the x-axis? Odd crosses. Think odd people cross you. They make you angry. Odd people don't make me angry, but people do not. So odd makes you angry, crosses. So this does cross the x-axis at x equals 2. I'm not going to write that in there, but at that 0, I know that it crosses the x-axis. Your graph is either going to go from low to high through 2, or it's going to go from high to low through 2, depending upon whether that graph is increasing or decreasing. And I can tell that once I figure out what my overall left and right hand behavior is. Then we have a second 0. We have another 0 at x equals what? This one right here is x equals negative 1. What's the multiplicity? What's the exponents 2? So that's even. What does that tell you about the graph? Does it cross at 2 or does it kiss at 2? It kisses. So this does not cross the x-axis. So then I can actually sketch, make it very rudimentary sketch of this graph. So I'm going to sketch it right here. I know my zeros are at 2 and negative 1. I'm going to have a 0 here at 2 and 1 at negative 1. Now, what is the overall degree of this polynomial? It's not 3. You're thinking terms. This is all one term right now. If I were to take x minus 2 times x minus 2 times x minus 2, what would be my highest degree of x term I would end up with? When I get an x cubed? I would. We'll do one here in a minute, but I'll show you, I will. And then if I did an x plus 1 times an x plus 1, won't that give me an x squared? What happens when I take an x cubed times an x squared? X to the fifth. Can't I just add my multiplicities together? Don't I have an overall degree of 5, and I got that degree by adding the multiplicities together, the exponents together. We can only do that when it's in this form. So that means the overall polynomial has a degree of 5. Is that an odd or an even function? So it's odd. So what does that tell you about left and right hand behavior? Or do they agree or disagree? They disagree. Now, you can figure out what your leading coefficient is going to be, positive versus negative. See how I have a positive x here? When I multiply it to 2 more positive x's, won't I get a positive x cubed? Same thing happens here. If I take a positive x and multiply it to another positive x, I get a positive x squared. Positive x cubed times a positive x squared gives you a positive x to the fifth. The only way for this x to have a negative coefficient is if maybe this were written backwards, like 2 minus x. Then the x would be negative. And when I cube a negative, what happens? You get a negative. So this one, if this one were written backwards as x or as 2 minus x, I would actually have a leading coefficient that would be negative. Because no matter what, if you have an even multiplicity, even if it were written 1 minus x, when that x is squared, it's going to turn out to be positive. So you only really have to look at your odd multiplicities. That's where it's going to make a difference. So this one, I have a leading coefficient that's positive. So does not tell me that I start up on the right. Because at 2, it's odd, I'm crossing when I go down. And then here I don't know what's happening. I hit that next 0 at -1, and it does not cross because the multiplicity is 2. It just kisses it and bounces right back off, and I know I'm going in negative infinity direction. The part that's left unsure is what does this look like under here? It could be more squiggly. Who knows? So let's throw it into our calculator. So I'm going to put it in exactly as it looks. X minus 2 raised to the third times x plus 1 squared. And then hit graph. So this part right here, between these two, that's my unknown part, and it kind of looks like a sort of a V, doesn't it? So this probably goes more in that direction. I wouldn't have known that from my side. You write that right. You need to pick me now. And good policy. I know you probably won't. All right, but doesn't my right and left hand behavior, aren't they correct? I figured those ones out correctly, didn't I? And didn't that kiss the graph right there at -1? Didn't cross. You want to make sure you could zoom in. So if I hit trace and I zoomed in, here's your -1. There it's kissing it, bouncing back, and here's 2. It's curving and going through. So we did a pretty good job.
So like, what if on a test we like do it wrong?
Then you're gonna get it wrong. But you should be able to tell you don't get your graph wrong. You should be able to tell based on all the things that we've been putting together. So you're not going to know this part of it unless it's in this form. And until you learn how to put it in that form, you'll get in this form.
But how do you know it's like up or not under?
Because my right-hand behavior I know starts up. Because it's an odd degree function of 5. And the leading coefficient we figured out was positive. Because my x is positive here. If I cube a positive, I get a positive. If I square a positive, I get a positive. Positive times a positive is a positive. So I know my leading coefficient has to be positive. So when it's positive, your right-hand behavior should be going up towards positive infinity.
But how come the dots are there? Like, how do you know?
It's because I start up and I go down. The only way to start up is if it's going from that direction. So then to get to this next 0, I'd have to go down and go back up somehow. And then because I know it's not crossing there, I just bounce right back off and go back down. If it didn't cross here and it bounced back up, which it could happen. It could bounce up, but then it'd have to reach some sort of maximum up here to go back down through, and it'd have to go through on the next one. Well, yeah, it'd have to for it to be an odd function. So an odd function, you've got one that's got to bounce and one that doesn't, if you're going to have any bounce at all. And so what that tells you is that some of your functions are, or some of your zeros are double roots on this multiplicity. They're not imaginary, they're just double roots. So in this particular one, we have no imaginary solution, just some double roots, or triple in this case. All right, look at B. I want you to do B all on your own. See if you can figure out what the graph looks like. Based upon the multiplicity, based upon figuring out what the leading coefficient is, positive or negative, whether the degree of the polynomial is even or odd. So go through that same process. So when you get an answer, I want you to talk to somebody around you to see if they agree about your multiplicities, your zeros, and then look at the graphs that you each drew and see if they look similar. And if they're not, we need to talk about why. I don't know, you chat. You decide once you're on. So talk, talk, talk. 2 heads are better than 1. Consider what the overall degree of the polynomial is, whether it bounces or crosses at those zeros.
Yeah, it's not. It's going down. Number 2 it does. Number 2. Yeah, so it does cross.
Talk to somebody and see if they agree with your multiplicities and the cross or don't cross it.
Okay. So if you like, I don't know. Yeah. Odd to
Whoa.
Okay, so let's stop and look to see what you have and why. So here's your zeros. You have 2 different zeros. You have 1 at x equals -3. Everybody agree with that? What's the multiplicity? 2. That's even. So because it's even, it does not cross the x-axis at x equals -3. It bounces off, either above or below. We'll have to figure that out in a minute. There's also 0 at x equals +2. It also has a multiplicity of 2, which means it also does not cross the x-axis. This graph doesn't cross the x-axis. It just touches it. And here's why. Think about it. No matter what value I put in for x, positive or negative, whatever this turns out to be in here, positive or negative, when you square it, what value will it become? Positive. Same thing here. Whether x is positive or negative, whether when you subtract 2, the value becomes positive or negative. When you square it, you get a positive. Positive times a positive is a positive. So the y value is always going to be 0 or positive. So can you envision now what it's looking like? The entire graph is in what quadrants? 1 and 2. Because 3 and 4 would be where y is negative. Alright, so I put my zeros here. The overall degree of this polynomial is what? What's the overall degree? How'd you get 4? You added the 2 and the 2 together. So that's an even degree function. Does left and right hand behavior agree or disagree? It agrees. So let's look at right hand behavior. Am I going to have a positive leading coefficient or a negative leading coefficient? Y positive. That x is positive, right? Squared is going to give you a positive. That x is positive. Squared is going to give you a positive. So we are going to have a positive leading coefficient. Doesn't that mean that my right hand behavior goes up? And that means the left hand behavior has to agree with it. And since this is a degree of 4, don't we have some experience to this that it kind of looks like a W? Or an M, depending upon whether it's going up or down? So I'm going to start with my right hand behavior must be going up, but it doesn't cross the x-axis here, it kisses it. So it must need to go up and come back down to kiss that one, and it bounces back up. So it must look something like a W in here. There can only be one maximum between those two. 0. There could be some wiggly squigglies in there. I don't know. You'll have to throw it into your calculator to see what happens. But for the most part, that's what it's going to look like. And this should be counted rounded and not going to be. Yes. Yeah. I'm looking at my leading coefficient. My leading coefficient has to be positive because x is already positive, right? So when I square a positive, I still get a positive. Square a positive, I still get a positive. Positive times a positive has to be a positive. Now the only place that that might have occurred where x would be negative is if this were written as 2 minus x. But if this were written 2 minus x, then x would be negative. But when you square that negative, isn't it positive? So you only have to worry about a leading coefficient being negative if your multiplicity, your degree up here, is odd. Because that's where if x happens to be negative inside the parentheses, that's where the odd would make it. So if like this had been a 3 and this had been 2 minus x, then that x would be negative because that would be a 3. And then multiplied to a positive, you'd have a negative leading coefficient, then this would be, the right side would be going down. That's how you code it. Is that, somebody else have their hand up?
Yeah, I did.
Okay. All right, so any other questions on that? You have to start gathering all of that data and using it to help you figure out what that graph kind of looks like. So I'm expecting that this is kind of dashed in there. It needs to be dashed because we don't know. But outside of the zeros, that should be solid. Because I know my left and right hand behavior based upon all that. Okay, then we have this thing called the intermediate value theorem. So I can still figure out what my graph looks like without a calculator by using the intermediate value theorem. This is a little harder. Please note that on Math Excel, you're going to want to use your calculator. I'm going to use it here to see how the numbers are big. Do you want to try to factor that? Does that look like fun factoring? No. And I can guarantee you that if you try to use root and garbage, it's not going to work out. So for right now, you don't know how to factor that yet. Emphasis on the word yet. What the intermediate value theorem says is, essentially, we're going to use a table of values. So using a table of values, and again, I've taken what your book has written and I've tried to simplify it for your needs. And letting, so this is an XY table, and letting the values for x be integers. You don't want any fractions, you don't want any decimals. Look for a sign change in the y column, which is your f of x column. this do you know what the word denotes means? This will be. This will be where a 0 will occur. So although we're looking at the y value in the table of values for sign changes, and I'll show you why that is in a minute, the 0 occurs between the x values because the 0 occurs on the x-axis. So if you look here, here's where y changes signs at this 0. So y here is negative, and it becomes less and less negative, but still negative until you hit the x-axis, and all of a sudden y becomes positive, doesn't it? Y is the graph, the direction of the graph. So here, though, if you happen to have a 0 where it just kisses the x-axis and bounces off, you're going to see negative, 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 negative 0, negative, 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 negative. Am I right? So the intermediate value theorem will not catch zeros where it touches the graph and doesn't cross through. So there's the downside to it. You would only notice that there was a 0 if your 0 was an integer. Let's say that that happens to be, I don't know, negative 1.2. You're not going to catch that using the intermediate value theorem because you're not going to notice that. You're going to think the graph goes negative, 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 negative. Your assumption will be here that you're finding the real zeros, and you're finding the zeros where the graph crosses the x-axis, not where it bounces off of. Now, I can look at this particular polynomial, and I know at most how many zeros am I going to have. 3, because that's the highest degree of that polynomial. So I'm looking for 3 sign changes at most. Now the question is, where do I start? How do I know where to start on my table of values? So here's my x and my y table. I'm just going to tell you right now, you're not going to have a really small or a really big 0 when you're doing this because you won't be able to calculate that by hand. So my suggestion would be you start at, I don't know, negative 3 or negative 4 when you don't have anything to look at. Like if I were to just plug this in to my calculator, so if I were to plug this in my calculator, 12x cubed, I would have a starting place because I'd be able to see exactly where it's crossing the x-axis. Minus 32 x squared plus 3x plus 5. Looking at that graph, can you see that my leftmost 0 is probably at negative 1 or somewhere between 0 and negative 2? Wouldn't it be? So starting at negative 3 seems reasonable. Yes?
So assuming that the zeros are
Reasonably close to 0 for your purposes. There are going to be ways as we go along you can narrow that down and decide how much farther out. But for right now, you haven't been given that information yet. So for right now, do make the assumption that it will be reasonably close to 0. Now if when we do this, you start at negative 3 and you don't get your 3 sign changes, and you'll see right away that at negative 3 it's a really big number for y, absolute value-wise. And you'll know that you hit a good spot. Because if you look at these graphs, they increase and decrease quite rapidly, don't they, at the ends? And so you're looking for that to occur. So you should have at the very beginning and ending of your y table some very large values for y. So I obviously wouldn't expect you to plug in negative 3, cube it, and multiply it to 12. Plug it in here, multiply it to 30. I wouldn't expect you to do that by hand on the test. So these numbers are going to be much smaller on your quiz because you're not going to have a calculator. Okay? But for our purposes, in Math Excel, I'd be using a calculator because that's crazy to do that by hand. So second table gets you to your table feature. And I'm going to plug in negative 3 all the way to positive 3. So I'm going to plug in negative 3, negative 2, negative 1, 0, 1, 2, and 3. You don't want to skip any numbers. If I skip an integer, then I might miss a sign change. And I want to go out far enough on both ends that I capture all 3 of my zeros. I know I'm getting 3 zeros because I have a polynomial of a degree of 3. So then look at your y values. We start out with negative 616. That's awesome that it's a big number. That means I probably got left enough to my leftmost zero. Then at negative 2, I have negative 225. So it's getting closer to the x-axis, isn't it? It's going from low and going high. So it's a good... I already know, by the way, what my graph looks like. Don't I have a leading coefficient that's positive? True or false? Yep. And I have an odd function, so does that mean my left and right hand behavior agree or disagree? Disagree. And with my leading coefficient being positive, I know it starts out this way. So right side goes up, left side goes down. So if my left side is down, that means I'm increasing. That makes sense that I'm getting bigger. All right, so then at negative 1, I have negative 42, getting closer to that x-axis. And at 0, I hit 5. Boom, what happened? What happened from here to here? It must have crossed the x-axis. There's a sign change. So it went from negative, then somewhere between negative 1 and 0, somewhere there, it crossed the x-axis and the y went positive. So this is a sign change. That means a 0 must have occurred, and the 0 occurs between the x values. So somewhere there's a 0 between negative 1 and 0. Negative 1 and 0 are not the zeros themselves, but it's somewhere in there. And that's as close as we need to get. So then go to the next one, 1. 1 gives us negative 12. What happened? Another sign change. So we have another sign change between 5 and 12. There's our second 0. I'm looking for how many more? How many more? One more. So at 2, I get a negative 21, no sign change. At 3, I get positive 50. What happened? Sign change. So if I had gotten a third sign change, I would probably go out to 4, and then 5, and see what's happening. Is it consecutively getting bigger and bigger and bigger? So it doesn't seem like we're ever going to get smaller. Or do I need to go in the opposite direction here and go smaller at negative 4? But you know how many zeros you should be capturing. So then from here I could sketch my graph. Never mind that we just saw it. From here I can sketch my graph. So I know that I have a 0, and my zeros are between, because I can't say what they are exactly, but I know that they're between negative 1 and 0, that's 1 0. Between 0 and 1, that's another one. And then between 2 and 3. So there's my 3 zeros. So because I don't know where, I'm just going to plot my point halfway in between. So halfway between 0 and negative 1 would be here. Halfway between 0 and 1 would be here. So those are quite close together. And then halfway between 2 and 3, that's a little further apart. Because my leading coefficient is positive and it's odd, I know I start up on the right hand side. Then I have to go down and come back up to get to that next 0. And I have to go up and come back down to get to that 0. But after that 0, I know I'm going down. This part is dotted because I don't really know what it looks like without the calculator. As you can see, it has quite the swooping going on, right? In fact, we can't even see that relative minimum over there. Questions on that? All right, the last part, you are being given the zeros and you have to actually write the polynomial yourself. Not so bad, it just requires some multiplication in your card. So I know if I have 3 zeros, I must have an x cubed as my final polynomial. So they have given me x is equal to 2, x is equal to negative 3, and x is equal to 5. That's what that means. So I'm working myself backwards from factoring. Prior to finding that solution, didn't I have a binomial? Get everything over to one side. So subtract the 2 to get it over to the side of the x. Wouldn't I have x minus 2? Right? And this one, add the 3. Wouldn't I have x plus 3? And on this one, subtract the 5, x minus 5. And you can set that equal to 0 or f of x. I don't care which. then you're gonna have to multiply two of them together first. You can't multiply all three together. So I'm gonna multiply those two together. Doesn't matter which two, just choose two. And so the x minus 2 doesn't change, but I am going to FOIL. So x times x is x squared. And then x times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. So at this point, you could either collect like terms and then distribute the x minus 2, or distribute the x minus 2 now. I choose to collect like terms. So these are my like terms. So I get a negative 2x when I collect those. So here we go again. I'm going to distribute the x. So I get x cubed. X times negative 2x, negative 2x squared. X times negative 15, negative 15x. Then I'm going to line up like terms when I distribute the negative 2. Negative 2 times x squared, negative 2x squared, same sign, they do not cancel each other out. Negative 2 times negative 2x would be a positive 4x. And a negative 2 times a negative 15 is a positive 30. So when I finally collect like terms, I'm going to squeeze it in here. I get an x cubed to the third. Here, I'm going to write it up here. So I get x cubed. These don't cancel, add and keep the sign. Negative 4x squared. Subtract and keep the sign the larger. Negative 11x plus 30 equals 0 or f of x, whichever you prefer. And then to graph it, I'm going to just sketch my graph over here. I have a 0 at positive 2, a 0 at negative 3, and a 0 at 5. My leading coefficient is positive, so what does my right-hand behavior do? It goes up. My overall degree is odd, so shouldn't my left-hand behavior go down so that they disagree with each other? And then I have to follow in terms of, I don't want to go up, I have to go down, then up, then back down. Because I don't know anything about multiplicity. At this point, you assume that all your zeros, they cross. So then let's do something with radicals. Here they've given you x equals the square root of 2, x equals negative square root of 2, x equals 6. So put your binomials together. Subtract that, so you get x minus the square root of 2. Add that, x plus the square root of 2. Subtract the 6, x minus 6. And again, you can set equal to 0 f of x. If I were you and you have radicals, they always come in pairs. I would multiply those together first. Isn't that the difference of two squares factor pattern? Plus and a minus are the same thing. So this multiplies as a squared minus b squared. So you get x squared is x squared minus, what's the square root of 2 squared? Just 2. If you don't believe me, FOIL it. The inner and outer terms will cancel. So then multiply the x squared through. X squared times x is x cubed. X squared times negative 6, negative 6 x squared. Negative 2 times x, negative 2x. Negative 2 times negative 6, positive 12 equals 0. We have no like terms to collect. So again, I have a cubic. I know where my zeros are. So I have a 0 at 6. What's the square root of 2 decimal-wise? Like 1.4. So I have 1 at positive and 1 at negative. It's odd. My leading coefficient is positive. So the left and right hand behavior are at odds with each other, and the right hand's going up. So again, this one's going down, up, and down. So you ought to be able to finish your 2-3 homework at this point.